Section 2.5, rates of change over intervals, is the most algebra section that we're probably going to do all semester. Okay? We're going to do a fair bit of algebra in this section. So for those of you who are like, I'm pretty good at algebra, I really like it, then this may be your section. And for those of you who are like, man, I hated algebra, I'm really sorry, but just bear with me for one section. Okay? So what we're going to talk about is we're going to talk about the actual derivative formula. This is the derivative formula. The limit as h approaches 0 of f of x plus h minus f of x over h. F prime. Thank you for asking. Yeah, F prime. So it's all caps on my screen. It's not all caps in your paper, but you should know this formula. It's really important. I can guarantee you there will be a question using this formula on your exam, without question. Okay? So I can only necessarily speak for Doran because he was the one who was in my college algebra class last semester. But if you've taken college algebra at this university, you've calculated this quantity before. You may or may not have done the limit part at the beginning, depending on if you've ever had a calculus course before, but you've calculated the part in parentheses. And it has a special name. It's actually called a difference quotient. And the only part of this here that's calculus is that limit part at the beginning. That limit part at the beginning, right, we talked about limits. That was a big component that we talked about in Chapter 1. Makes it a calculus topic. So I have a daughter who's in pre-calc in high school right now, and she just recently, it's been within the last week, has been doing difference quotients. Okay, it's a pre-calculus topic, a college algebra topic. So you've probably seen it before. I do present it a little bit differently. So if you like the way you did it before, and you didn't have me, because Doran's going to be like, I already saw this before. But if you like it the way you did it before and it doesn't look like mine and you feel comfortable enough that you think you can process through that, okay, it's great. But I would like to show you what is called the 4-step method. This is the method that your book does to try to lead you through how to find a derivative with the limit definition. So the first thing that you do is you calculate f of x plus h. That's step number 1. The next thing you do is you subtract off of that f of x. So if you're comparing that back to this equation now, that means you've done the whole numerator. You calculated f of x plus h, you subtracted off f of x. So if you're working your way inside my circle that I made before, the next step is that you would divide by h. Once you've done that, you have found a difference quotient. The last step to actually finding the derivative then is to take the limit as h approaches 0. So the other approach to doing this is to do all those steps all in the same time. Okay, so if you're like, well, what did I do before? Because I don't think it was that. That's probably what you did. That's sort of a traditional calculus approach. When I teach our engineering calculus, that's typically how our book does it. So I present it that way as well. However, this book presents it into 4 different steps, a little bit bite-sized chunks, and I think it's actually really a good way of thinking about it. So I'm going to show you how we do that with a specific equation. Now, it is valuable and important that you realize that you're going to help me out a whole lot, and you're going to help the grader out a whole lot if you number the 4 steps if you choose to do it this way. Okay, so when you do step 1, write this step 1. You'll see me do it here in a moment. All right, so our equation is 4x squared. So the first thing that we're going to do is to calculate f of x plus h. That always throws people a little bit. If it's the first time you've done it, or maybe the first time in a long time that you've done it. If I were to tell you to calculate f of f4, let's just do f of 4, what would you do? Somebody say it. Somebody's saying it already. Yeah, you'd plug 4 in for x, right? Yeah. Well, it's the same thing for f of x plus h. We plug in. Okay, that wasn't what I meant to do. We plug in x plus h where the x's are. Okay? So, we will have the 4. In place of my x, I will have x plus h, and then we will square it. Okay? Please do not try to distribute a square. It's not correct mathematics, and I'll show you why in just a second. But let me remind you what you do instead. Whoops, I need my 4 still. X plus h squared means x plus h times x plus h. So we're going to distribute that out. I'll do my 4 last because I think that's the simplest way to do that part. And we will do the first terms, the outer terms, the inner terms, and the last terms. So the first terms are x squared. The outer terms are xh. The inner terms is another xh, and then the last terms are h squared. We can combine the h's in the middle. And then we would distribute our 4 through. 4x squared plus 8xh plus 4h squared. Okay, that's the messiest step of the whole process because it's got the distribution part in it. Okay, so that's step 1. Any questions on step 1? All right, so I mentioned I'd show you, and I will real quick. It's very tempting to think that we can simply make it x squared plus h squared. Obviously, you saw me multiply it out, but why is me multiplying it out right and this one wrong? And let's just use some real quick numbers so you can see. Let's say that we had 2 and 3. What's 2 plus 3? Don't everybody answer at once. 2 plus 3 would be 5, right? What's 5 squared? 25, thank you. If this were true, then I should be able to do this. What's 2 squared? What's 3 squared? 4 plus 9 is 13, and these two are not equal, right? So there is no distribution across parentheses of exponents over addition or subtraction. That does not work. Okay, so let's go back to our problem that we were working on with step 2. So step 2 is to take f of x plus h and subtract off f of x. Well, f of x plus h was my previous step, which was 4x squared plus 8xh plus 4h squared. And I'm supposed to subtract off the original f of x, which is 4x squared. Okay, so down here, I will subtract off 4x squared. And when I do, what do you notice?
Cancels.
Yeah, it cancels. So I now have these canceling, which leaves me with just 2 terms, 8xh and 4h squared. Now, here's the deal. If you did it right, you should have an h in every single term when you're done. 8xh has an h in it. 4h squared has an h in it. If you don't have an h in every single term, there's an error in what you've done so far. And you need to go back and find it. All right, so step number 3 then is to divide by h. So we're going to take the previous line of work we just did, 8xh plus 4h squared, and we're going to divide by h. That's why it matters that there's an h in every term that you have, is because I want the h's to divide out. So this bottom h, it will cancel with one of the h's in each of the terms above. On this problem, that leaves me with 8x plus 4h. okay? Again, everything I just did is actually not calculus. It's maybe not especially the easiest algebra, and it isn't for sure, but it's all algebra. We do it in college algebra here at OBU. Step 4 is our calculus step. So, step 4, need a black pen now, just a sec. Okay, so step 4 means that we're going to take the limit as h approaches 0 of whatever I had left from step 3. Well, that was 8x plus 4h, right? So I don't say limit equals. That doesn't make any sense. You would never tell me square root equals 4, right? Square root's an operation. It doesn't make any sense to say that it equals something. It's got to be the square root of something that equals 4. The same thing is true for limits. It's the limit of something that equals something else. In this case, it's the limit of 8x plus 4h. But now we're actually back to what we did in, I think it was 1-3, where we're evaluating, if we can, and we will be able to at this point always, the h as the value 0. So this is 8x plus 4 times 0, which gives me just 8x. And what we found at the end is that this is the derivative, f prime of x, that we were looking for. Right here. We were told limit as h goes to 0.
So you just plug in a 0 for h.
Because that's what it means for the limit to approach 0 from an algebraic equation, or an algebraic standpoint. It's part of the, that last one right here, take the limit as h approaches 0 step. Okay? And so we're doing it algebraically. We will always be able to plug the h in if we have appropriately canceled out the h's the way we should have in step 3. Okay, now for those of you who really are dying to ask, but maybe you're too shy to ask me, if I know another way to do this, do I have to do all this limit stuff? What do you think the answer is? Yes. The answer is yes. This whole section's point is helping you to understand that this is where the derivatives are coming from. When we get later into section, it's not even 2.6, I think it's 3.1, yeah. When we get to section 3.1, which is soon, it's next week, you will have some simple derivative rules where you can actually look at this equation right here and just tell me it's 8x. The derivative is going to be 8x. And those of you who've had calculus before know exactly what I'm talking about. And if you haven't, that's totally fine. But right now, you have to do the limit. And the reason you have to, well, there's a couple of reasons. Number one is that you have some kind of appreciation for the fact that you don't necessarily have to do it for the rest of the course. That's nice, right? And why do you not have to do it for the rest of the course? Because other mathematicians long before you established, hey, look, it looks like there's a pattern. It always does this. It always happens this way. I bet we can shortcut the system and allow people to do stuff faster, and that's exactly what happened. Okay, so it gives you some appreciation. I will ask you to do one question with a limit definition on the test, just one. Okay, so it would look something like this. Could be a more complicated equation, but this is what you would be asked to do. Okay, so we're going to practice on a few more, but before we do, any questions on this one? Okay, so we're going to flip over to the next page. You have a new equation. So we started out on purpose with an equation that had only one x in it. Not all equations do, so I want you to see what happens when you have more than one x in it. The process isn't any different, it just means that I have more to evaluate. Okay? Okay, same 4 steps. Step number 1, this is my function g, so I'll call it g of x plus h now. And that step means every place I have an x is replaced with x plus h. So negative 2 times x plus h squared. And then I have plus 3 times x plus h. Everywhere I have an x is replaced with x plus h. So it's often that you end up with an x plus h quantity squared. I'm going to flip back over to my previous screen to remind you when we did that, what happened. We distributed everything all out, right? We combined like terms. And we ended up getting x squared plus 2xh plus h squared. So I'm going to use that fact right now, but if you need to see it, a few more times before you're comfortable doing that, you can show the workout for that. But I wanted to show you that it's also okay at this point to say, hey, I know that this is now 2 times x squared plus 2xh plus h squared. It's called binomial distribution, okay? You're welcome to distribute the 3 through the next piece, either now or in a minute. So 3x plus 3h. And then we need to distribute our negative 2 through the first one. So I have negative 2x squared minus 4xh minus 2h squared plus 3x plus 3h. So the process isn't any different. It's just happening in more than one place. And that's it for step 1 because none of those pieces combine. Okay, step 2 then is to take that same equation same expression we just got and to subtract off the original g of x equation. So that's negative 2x squared minus 4xh minus 2h squared plus 3x plus 3h. And I'm supposed to subtract off everything from the original g of x equation, which was negative 2x squared plus 3x. That's the original g of x equation. That's why it shows up there at the end altogether after the subtraction sign. Okay, so here's the thing. Everything that's currently in parentheses has to cancel with something before. The reason I can tell you that, based on what I told you before, is that I have to have everything that doesn't have an x or doesn't have an h in it eliminate itself with something else. And everything in that parentheses has no h in it. Okay? So you can do one of two things. If you want, you can distribute the negative through. That's fine. Or you can pair them up as they are. You can notice that this is to negative 2x squared, and this is minus a negative 2x squared. They're canceling. They're inverses of each other. This is a positive, sorry, I didn't do the right one. This is a positive 3x, and this is subtracting a positive 3x. It cancels as well. So step 2 is a really good step for consolidation. It consolidates what you had from step 1, always. And so you are ending up left with negative 4xh minus 2h squared plus 3h. In particular, less than what you had before. And everything has an h in it, doesn't it? It does. Which allows us to do step 3 and divide by h. Okay, so let me just make a comment right now real quick. You'll notice I'm going to keep doing it on all my examples. If it helps you to label them the way I have, that's great. You don't have to. But at the very least, give me some numbers that tells me which step you're on which place. I don't want to have to look at this work and say, oh, look, they went from here to here, and they actually changed it, but they changed it because they really changed steps. Okay? Make it helpful, right? Put a number on it that tells me I'm moving on to step 2 or step 3. So I'm taking my negative 4xh minus 2h squared plus 3h, and I am dividing by h. Make sure that every term in the numerator has one of its h's eliminated, so there's only one h in the first piece, 2 in the second one, so I'll eliminate 1, and 1 in the third one, eliminate with the one on bottom. That leaves me with a negative 4x minus 2h plus 3. All right, the caveat to step number 4 is that you do need to show the limit notation, right? You're going to write down limit as h goes to 0, and you're going to take what you had from step 3 and put it down there. So that was negative 4x minus 2h plus 3. I don't necessarily have to see you plug the h in. So either show the h being plugged in as 0 or don't, but either way you're going to end up eliminating the term that has the h in it because the 0 will wipe it out. So I'll show mine for this part, but if you want to leave that part out, you could. So negative 4x minus 2 times 0 plus 3. And like I said, this piece goes away, right? So I'm left with negative 4x plus 3, and that is equal to g prime of x. Sorry, now on the very bottom of the screen.
So you said with these, we're always going to have a limit as h approaching 0?
Yes, always. It'll always be h approaches 0. Doran?
That was my question.
Awesome. Yeah. So the last step will always be plugging in 0 for h. I mean, that's really what it'll amount to. Plug in 0 for h. All the h pieces go away. Okay. The more we do them, the more they're going to become comfortable, so we're going to do another one, okay? Let's take a look at C. Any questions on that one before I move on, though? Anything else? Okay. Same directions. We now have x cubed minus 5x. So the last two examples that I've shown you have shown you only what happens when there's a power that's a power of 2. Power of 3 is something different. It just makes it longer, okay? More work in the process. So I don't think I'll be able to do this all on one screen. So the first step that we're going to do is to calculate k of x plus h. As you're doing this, if you end up changing your function names to all be f of x, I am not concerned about that at all. If they give you variables inside of the function that are not x's and you end up changing all your variables to x's, I am not concerned at all, okay? So don't fret about stuff like that. That's notation. It's not a big deal. I'll try to keep mine consistent when I'm using on the board, though. So this is k of x plus h. So I have x plus h everywhere I had an x. So now I have x plus h cubed and minus 5 times x plus h. Okay. Now, x plus h cubed is a little messier. I kind of like to make note that if you do x plus h cubed, it looks like this. Actually, I'll put this back down on the thing itself. Let me move it down there. And then I have minus 5 times x plus h. So this was the note I was trying to make. Two of these multiplied together, we already know. We've done them on the previous problems. So I'm just going to put that piece in that I already know. I know that that is x squared plus 2xh plus h squared. And that has to be multiplied by x plus h. And we'll go ahead and distribute the 5 through if you'd like. At this point, you could wait if you want to, too. It's not a big deal, but we have negative 5x and negative 5h at the end. Okay, so binomials, right? When you have two terms times two terms and you multiply, we talk about first, outer, inner, last. A lot of times, anyway, you've probably heard it FOIL, right? This is not a binomial times a binomial anymore. I have a trinomial, 3 terms by 2 terms. The process still works very similarly, but we'll just do it piece by piece. I'm going to take the first term x squared, and I'm going to multiply it by each of the terms in the next set of parentheses. So if I multiply x squared times x, I get x cubed. And x squared times h gives me x squared h. Okay, is that all right? That's the yellow ones. I'm going to use red next. 2h, we're going to do the same thing. We're going to multiply it by x, and then multiply it by h. So 2h times x is 2xh. I messed something up. I'm so sorry. Please edit this with me. There is a typo here. Let me go back a little bit to my red circle since it's too small. This in the middle should say 2xh. So sorry. Okay, that's what we're supposed to be distributing as 2xh. All right, so 2xh times x would be 2x squared and h. And then 2xh times h would be 2x and h squared.
Is your first x, is it x squared or x cubed?
The first one is x, supposed to be x cubed. I typoed again. Too many things going on. I'm so sorry. Thank you for helping me keep on track. It should be x cubed. X squared times x is x cubed. Okay, last piece. We have, I'll do it in this like purple color, this h squared, and it will be multiplied through. So h squared times x is x h squared. I just put my x's in front. It doesn't matter whether you do x's or h's before each other. I just was trying to be consistent. And then the last one, h squared times h would be h cubed. Then I have minus 5x and minus 5h. I'm glad I'm finished because I'm out of room on my screen. Okay, so I wasn't joking when I said there's more going on, right? However, there are some pieces that can combine here. Do you see some? This is x squared h and this is x squared h, right? So I have 1x squared h and 2x squared h's, which gives me what? 3. Thank you so much. 3x squared h's. And then I actually have an xh squared and an xh squared here as well. Again, there's 2 of one of them and 1 of the other, making a total of 3. So I have 3 xh squareds. And then the rest of it doesn't have any combining abilities. So I have h cubed minus 5x minus 5h. Okay, any questions on that one? We're done with that step. This is step 1. Remember, step 1 always takes the longest. Everything else moves much more quickly. So don't feel like, oh my goodness, I'm only a fourth of the way there. You're not. You're about halfway there, even though we're only on step 1. Okay, I'm going to copy this to my next screen so I make sure that I don't typo anything. Okay, so my step 2 is to take g of x plus h and subtract off g of x. So my g of x plus h is already written there because I moved mine over. And then I'm subtracting off the original g of x equation, which was x cubed minus 5x. Remember, step 2 is always your friend. Step 2 makes things less, makes them smaller. So we can consolidate, we can eliminate certain pieces. Everything in parentheses will eliminate with something earlier unless there's an error that you've made. This is x cubed, and this is x cubed, right? X cubed at the beginning minus, because there's a subtraction sign before my parentheses, the x cubed at the end. I have a 5x, negative 5x right here. And then I have minus a negative 5x right over here. So those eliminate as well. So 2 pieces this time eliminated. So let me write down what we're left with. We have 3x squared h plus 3x h squared plus h cubed minus 5h. I only used half the screen that time, right? Much shorter. What's step 3? Divide by h. Again, this is a good step because, actually anything from step 2 on is a good step because everything makes it smaller, right? Step 2 eliminates a couple things with addition and subtraction. Step 3 eliminates some h's from the situation, and then step 4 eliminates all the rest of the h's. So we're going to take each of these pieces, 3x squared h plus 3x h squared plus h cubed minus 5h. That's my numerator over an h, and each term has one of the h's eliminated. So notice the h cubed term becomes h squared. So it's still there, a couple of them, but not as many. Now I have 3x squared plus 3xh plus h squared minus 5. Step 3 is in the books. Last step, the limit as h goes to 0, and I write the next part exactly like I had the ending of step 3. 3x squared plus 3xh plus h squared minus 5. And everywhere that I have an h, I put in 0. And if I do that, this term equals 0, this term equals 0. And I'm actually just left with 3x squared minus 5. And that is my k prime of x. I changed it up here, didn't I? This was supposed to be k. Sorry, too many letters changing. It's k of x equation. But k prime of x is what my variable, or my equation name was to start with. So cubes aren't bad. They're just a little more work. Okay. You're going to like the next three compared to what we've done. They're easy. You ready? No joke. I'm not kidding. I'm not being facetious. They really are. They're way easier. You ready? Okay. So everything we did before had terms that were squared, or that last one was terms that were cubed. The next three we're going to take a look at don't have any powers. Okay? Their process is still the same. We're going to do step 1, which is, in this case, it's k, right? So k of x plus h, which means we rewrite it with an x plus h where the x is. And so very nicely, this leaves me with 7x plus 7h. So far, so good? Step 2 is to take that value, k of x plus h, from step 1 and to subtract off the original k of x. So this is 7x plus 7h minus 7x, because that's k of x originally given. And again, still in step 2, things got simpler. So I'm left with 7h. Step 3 is to divide by h. So we'll take 7h and divide by h, and we get 7. Now 7 is not a very exciting thing to take a limit of, but you know what? Sometimes very exciting is not really bad. It's a good thing. So we're going to take the limit as h goes to 0 of 7. Technically, we're going to plug in 0 for all the h's where they don't exist because they're not there, right? And we will be left with the same 7 that we currently have. So k prime of x is actually 7. Now, let's just pause for a moment and think about why. Question D, k of x equals 7x. What does that equation look like? What's its shape? Did you say something, Sarah? What is the original equation? What does this equation look like?
Exponential or logarithmic?
It's a line. I think that was Isaac, yeah. It's a line. Just the line y equals 7x. If you remember, derivatives are finding slopes. What's the slope of the line y equals 7x? 7. So yeah, it has to be 7 at the end, because finding a derivative is finding a slope. It's just that finding a slope of a line is really easy because it's just got one slope. But all the other curves, the slope changes because the shape of the lines change, or shape of the curve is changing all the time. So given that information, what am I going to get when I do the same thing here on letter E? What's the slope of this line? 4. So I'm going to go through all the steps that I just did again, and I know I'm going to get the answer 4. Okay, have to. So let's go through the steps to verify it. So we're going to do step 1, r of x plus h. So this is 4 times x plus h plus 2. It's 4x plus 4h plus 2. Step 2 is r of x plus h minus r of x. So that's 4x plus 4h plus 2. And then minus 4x plus 2, because that was the original equation for r of x. The 4x's cancel. The 2's cancel. That leaves me with 4h. Step 3 to divide by h. 4h divided by h equals 4. And then my last step, the limit, as h goes to 0 of 4 is equal to what? 4. And that was my r prime, or derivative of r, for our equation. Okay, f just looks weird. We're going to do f together, but just recognize before we even start that I know it looks weird, and that's okay. You're going to be okay with weird for a moment, but I want to show you how to do it. Yep, Mark.
Because there's no x, there's nothing to replace with x plus h, so we're going to 6.
Yeah, so we're going to do that. You got it. Okay, so Mark's exactly right. I didn't realize you were moving on to the next one without me, but you're right. Yeah, so on the first step, n of x plus h, Mark's exactly right. There is no x to replace with x plus h. Like, there's not one. So it is just 6. Okay? It's kind of like over here. There was no h to actually plug in 0 into. Okay, so we were just left with 4. So step 2, n of x plus h minus n of x means I have 6 minus 6, which is 0. So I guess you could say this is the one caveat to what I told you before, where everything has an h in it at this step. Technically doesn't. But you can still divide 0 by h. It's 0 divided by h. Don't overthink this. Somebody say it for me. 0. Thank you. It is 0. And your step 4, where you're taking the limit as h goes to 0 of 0, is also 0. This is h prime, I'm sorry, not h, n prime of x. So again, let's go back up to the equation and talk about why this has to happen. What does this equation look like? A horizontal line. What is the slope of a horizontal line? 0. And that's exactly what derivatives are finding, is slopes of lines. The slope of that line is 0. So yes, it's going to be 0 when I'm done. Looks weird to do all this sort of weird process with lots of zeros everywhere, but it still works. The process still works. It just feels awkward. Okay, we have one more example, I think, on the next page. Yeah, one more example, 2 parts. This one has some language, like verbiage and stuff with it, so I wanted to show you what happens once we sort of move away from just a traditional algebra-looking equation and it actually has context. An object is dropped off a building. Ignoring air resistance, the height above the ground, t seconds after being dropped off, is given by f of t equals negative 16t squared plus 100 feet. Part A says, use the limit definition of the derivative to find the rate of change equation for the height. Okay, anytime you see that phrase, limit definition of the derivative, that's this whole section where I've got the limit and I've got my 4 steps. It's the 4-step method. Okay, so we're going to use this equation, ignore the notation in the units and everything. We still have an equation. It works just like the last equations we were doing. If it bothers you that there's t's in there instead of x's in there, just change them. I'll keep mine as t's. I do curlies underneath my t's so that they don't look like plus signs. That's my one problem with t's. They can start looking like plus signs if we're not careful. But we're going to do this limit definition of derivative. So step 1 is f of t plus h. So I have negative 16 t plus h squared plus 100. Good? Now, we did x plus h squared at least twice, so we know that this should be t squared plus 2th plus h squared. If you're still not sure if you believe that or if you can see where that's coming from, do it all out. FOIL it out, distribute it out, and it will work that way. Plus my 100. I'm going to distribute the negative 16 through. So negative 16t squared minus 32th minus 16h squared plus 100. Okay, that's step one. Before I switch screens, I want to make sure everybody's good with step one. All right, so step two is to take f of t plus h and subtract off f of t. So here's f of t plus h. And I need to subtract off f of t, which was negative 16t squared plus 100. Barely get it in there. Again, everything in parentheses cancels. So there's my canceling the 16t squareds, and here's my canceling my 100s. So this leaves me with negative 32th minus 16h squared. Much shorter than it was before. What's step three? Divide by h. So I have negative 32th minus 16h squared. Divide by h. There's an h from each piece of the numerator and the h in the denominator that all cancel with one another, leaving me with negative 32t minus 16h. Step 4. Limit. As h goes to 0, and I will take this whole quantity to put in there, negative 32t minus 16 h. And if I evaluate the h as 0, not the t, but the h as 0, I get negative 32t. That's f prime of t. That's the derivative of my equation. Any questions on that? Okay, we're going to do an interpretation step for part B. Okay?
So that,
Oops.
what we just did is the rate of change equation.
That's the rate of change equation. And specifically, it's because it uses the word, I'm going to highlight it too actually here, or equation. Yeah, it doesn't say model. We will do stuff with models, but they aren't happening yet. All right, so we'll get to the point where we're sort of thinking about it more of a modeling sense. We just haven't got there yet. I think 3.1 is when we get there actually, so we still have a couple class periods. Okay, part B then over here asks us to use that answer to determine how rapidly the object was falling after 2 seconds. Okay, so remember, derivatives tell us how things change. So that's what's answering this question. How rapidly, in this case, is it falling? And the reason I know it's falling is because it is negative, by the way. Negative 32t, so this is decreasing, right? So after 2 seconds, so we're doing, f prime of 2 is negative 32 times 2, which is what? Negative 64, you got it. And then I need units, right? Like this is actually context, like it's doing something with some units. What are the units on this?
Feet per second.
What was it again?
Feet per second.
Yes, ma'am. Feet per second. I'll flip back to my screen on the other page to show you where it comes from if you weren't for sure. It is feet per second. And that goes back to what we just did in the previous lesson, right? 2.2. We talked about the fact that over here, it would be the output per input. The output is feet. And the input is in seconds up here. So it's feet per second. Any questions on that? All right. So lessons for 2.3 and 2.5, today's lessons, are both going to be due then on Tuesday. We've got a couple days at the Success Center if you need help on some of these, especially if maybe some of your algebra is rusty. Or come see me in my office as well. And we will have a question time at the beginning of class next time as well, just like always.